Yes. Good morning. Good morning to all. Very good morning. Now we are going to discuss about the second chapter revision. Second chapter revision. Okay. Just a minute. Just a minute. I am going to take your textbook. Just a minute. Is it audible to you? Is it audible to you? Now we are going to discuss about what chapters. Okay. Yeah, now we will discuss screen share, science textbook. Yes, look here. This is a pin holder. Pin holder. All of you would have seen a pin holder in your school office. You may have seen that in this pin holder, some pins are attached to the top R cap. So their pin holder is there. You are looking that pin holder. At the top, some pins are attached. Okay. So that pin holder you may see in your school office or somewhere. Whenever you go to the office where they are using the pins, there we will find out these pin holders. Okay. So that pin holder at the top of that means at the cap we will see some of the pins. So in some pins are in that pin holder also. Some are inside the pin holder box. So there some questions are there. Based on that, we are going to find out the answers for that questions. Okay. Why do the pins get attached to the cap of the pin holder? Cap of the pin holder. Just a minute. Yeah, I got a phone call. Due to that, I stopped. Okay. Now, is it audible? Okay. I'm going to explain. Now it is going to start. So, why the pins are attached to the cap of the pin holder? There is a magnet. That is, we are going to learn. Then what could be there in that cap? So, in that cap also. So, for the three questions, answer is a magnet. Does it attract object other than pins? What are they? So here the third question, if we use other than the pins, other objects which are made with the iron objects itself attached to the cap of the pin holder, remaining will not attach. So finally, what is the conclusion? In that cap there is a magnet. Next we are going to discuss about. Okay, I think it is clear to you. You might have seen some materials stickers stuck to the doors of an iron almara or refrigerator, etc. Okay, so that picture you will see that. So back of that stickers like goddess stickers, back of those stickers, magnet is there. Magnet attracts the iron objects because this refrigerator or almara which are made with the iron. So that is the reason we can stick to that. Okay. So what is the answer? Magnet is the answer. What is there in those stickers which make them stick to the iron doors? So what is there here also? Answer is a magnet. So which means magnet attract iron objects. That is the reason. Do they stick to wooden doors or plastic doors too? No. It will not stick to the wooden doors or plastic doors because it is only attract iron objects. So activity one we are going to discuss here. Here. So finding objects that get stuck to the cap of pin holder. So here we have to take some materials and we have to test with that pin holder cap. Some are attached to the pin holder cap, some are not attached. So what are those? The activity one already you learned it. See the objects names. Take a pin holder from your school office, drop some pins, jump clips, iron nails into it. What do you observe? Uh, do the same with the piece of paper, a pencil, and eraser. So first three are pins, jump clips, iron nails made with iron. Those three attached to the cap of the pin holder. So next paper piece, pencil, eraser will not attach it to the cap of the pin holder because those are not made with the iron. You would notice that some of these objects, pins, jump clips, iron nails get stuck to the cap of the pin holder, while other objects, so pencil, eraser, paper fall into the pin holder. So that we will find by doing this activity. Why does this happen? So what is the reason behind that? So the cap of the pin holder contains a special material which attracts substances like iron pins, iron nails, jump clips. Okay, iron pins, iron nails given here. Similarly, the materials stickers also have a special material that back at the back so that they can stick to iron doors. That special material is a magnet. Already here we wrote. So I am going to show to you. Here we wrote that answer. So for this, okay. So for this question, we made an answer that is a magnet. So here is a magnet. You can see. So back side of the stickers or pin holder cap magnet is there. Magnet attract only iron objects. That is a conclusion of this activity. Okay. What materials is needed for making magnets? Have how were these magnets discovered? So what materials are required to make a magnet, and who discovered and how were discovered these magnets? About that, let us try to find out the answers to these questions. Okay, coming to that, Magnus. About the Magnus, we discussed. He was a good shepherd. Around 2,500 years ago, there lived an old shepherd named Magnus. That shepherd name was Magnus. He used to take his goats and sheep to the hill areas for grazing. He had a maybe he is a shepherd. He used to take that goats and sheep to the hilly areas for grazing. Okay. He always carried a wooden stick which had a iron cap on one its lower end. Okay. That shepherd always carry one of the stick. So one end of that stick has an iron nail along with the cap. Okay. One day while his goats were grazing, one day every day how he used to take that the same kind. One day while his goats grazing, Magnus dipped his stick into a spring of water and poked at the pebbles and stones at the bottom with it. So he sat near the water streams. By using this stick, he is poking, so pushing into the water, and inside the water some stones are there. He is hitting that stones with that stick. The stick, one hand has an iron cap and nail, no? So that is poking inside that pebbles, stones. Okay. Suddenly, he felt something pulling his stick. When that when he took it out of water, he saw a stone stuck to the iron cap. So something is pulling inside that water. So he felt that, and immediately he took it back that stick from that water. So when he took out of the water that stick to that iron cap, one stone stuck. Okay, the stone which Magnus pulled out was called lodestone. So that is the first magnet which we call as a natural magnet. It is a lodestone. It is a natural magnet and possesses the properly of attracting iron. Okay, so it is attracting irons itself, the properties of that. Okay, that characteristics of the stone attract only iron objects. So that stone was discovered by magnet. So that is the reason this material is called magnet. Magnus discovered magnet. The first natural magnet is a lodestone. So this is one of the important bit. The first natural magnet is a lodestone. Okay, here types of magnets we are going to discuss. How many types of magnets are there? In our syllabus, we are going to discuss about 4 types of magnets: bar magnet, ring magnet, disc magnet, horseshoe magnet. These are the 4 different types of or different shapes of magnets. Okay, the shapes we will see in that. One is a bar, one is a ring, another one is a disc, and a horseshoe magnet. These are the shapes of the magnets. Now here, activity 2 we are going to discuss. What is activity 2? Finding materials attracted by the magnet. So here some material list is given. These are all we are going to test with the magnet. Okay. So which are attracted and which are not attracted, that we will write in this box. Attracted, not attracted. The last column. Material. Name of the object. Material which of the object is made of iron, plastic, aluminum, wood, glass, or any other. And attract or not attract. So like this we are going to write in the tabular form. So one after one I am going to explain. So bar magnet. Okay. Take one bar magnet, nail attracts, jump clip attracts. Okay, nail made with iron attract, jump clip also made with the iron attract, plastic scale made with the plastic not attract, piece of a glass, so made with the glass not attract, brass not attract because made with the brass, paper, so pulp of that tree not attractive, iron bolt made with the iron attractive, pen made with the plastic not attractive, blade made with iron attractive, pencil made with the wood not attractive, knife. So if it is made with iron attractive, if it is made with the stainless steel not attractive, stainless steel spoon not attractive because it is a steel. Piece of chalk, so made with the calcium not attractive, wood not attractive. Okay, and touch the magnet of each item. So these are all we use to touch with the magnet. So the objects which are made with the iron, those only attract. Which are not made with the iron, those are not attract. So here two questions are there. So these two questions are here answers. Which materials are attracted by the magnet? So the materials which are made with the iron, nickel, cobalt, those are attracted by the magnet. The other than the iron, nickel, cobalt, those are not attracted. So here, this is one of the answer for one question. So already I gave you question. What are magnetic materials? The materials that are attracted by the magnet are called magnetic material. The materials that are attracted by the magnet. So which materials attract by the magnet? Those are magnetic material. Which materials are not attracted by the magnet? Those are non-magnetic material. Okay. So second question, what are non-magnetic material? Non-magnetic material which are attracted by the magnet, those are magnetic. Material which are not attractive, those are non-magnetic materials. There is a difference is there. Two questions. Two questions are there. What are magnetic material? What are non-magnetic material? Material which are attracted by magnet, those are magnetic material. Materials which are not attracted by the magnet, those are non-magnetic materials. So two types of materials we are going to classify. Some attract by the magnet, those are magnetic materials. Some not attract by the magnet, those are non-magnetic materials. So clear. So here magnetic and non-magnetic classification you understood. Give your own examples for magnetic material. Okay. What are attracted by the magnet? Those are magnetic material. So in your classroom, in your house, which are attracted by the magnet, that names you can write. Those are magnetic material. And give your own examples for non-magnetic material. So which are not attracted. So I am going to give you some examples. For example, iron chair, iron desk. Okay. Window frame. Then whatever that gadi which is for our door. These are all made with the iron. These are all magnetic material. Pencil, paper, eraser, plastic chair. These are all non-magnetic material in our house. So remember about them. These are example for magnetic and non-magnetic materials. Next, we are going to discuss about yeah, because there is a magnet. Right. Next, we are going to discuss about magnets have the properties of attracting materials like iron. So magnet have some capability which attracts only magnetic materials. Okay. Right. This property of magnets, they can be used to separate some mixtures. So they can materials we will use to separate some of the mixtures. What mixtures? Iron objects mixed with the plastic, glass, stainless steel, copper, aluminum. If these are all mixed, if we use a magnet, so from those mixtures we can collect only iron objects. Remaining all will be there itself. So that magnet uses to separate the iron objects from the mixtures. That is okay. Next we are going to discuss about activity 3. Look here, activity 3, what is there? Can we separate iron fillings from soil? So that activity, you know that take one bar magnet, rub it inside the soil. So inside the soil, different types of components are there. Soil is made up of different components. Okay, in that iron fillings also is there. If we rub that iron magnet, if we rub the magnet inside the soil, some iron fillings stuck to the magnet that we can separate from the soil. So that is a activity we are going to discuss. Take a bar magnet and roll it in the soil in your school ground for some time. Pull out the magnet. What do you find? Does anything get attached to the magnet? Yes. When we rub the magnet inside the soil, some of the iron fillings are attached to the magnet. So that we may do in our school ground or anywhere where we rub in the soil. From the soil, we will collect some of the substances which are iron fillings from the soil by using the magnet. Do you find some dark particles of soil sticking to the magnet? Yes, we found. Okay, we found that. So those are iron fillings. So now gently remove these dark particles from the magnet and collect them in a sheet of paper. These are iron fillings. So that we call as a iron fillings. Okay, right. Coming to the next page. What we collected by rubbing the magnet inside the soil? Iron fillings we collected. Okay, iron fillings we collected. So next, keep these iron fillings in a box to use in further activities. That iron fillings we are going to use in the upcoming activities also. Which part of magnet attract more iron fillings? So both edges of the bar magnet. So both sides. Because what is there? From which part of magnet do you feel more difficult in removing iron fillings? At the both edges. For the both questions, answer is edges because at the edges attraction is more in bar magnet than the middle. So that's why the more iron fillings we will find at the edges. Okay. Next, more difficult to collect that iron fillings from the edges. That is the answer. Okay. Now, poles of a bar magnet. So those we called as a poles. The both edges. Does the property of attracting iron fillings remain the same for all parts of a bar magnet? No. What I told now. So edges attraction is more than the middle. So that's what the attraction is more at the edges. Those edges we call as a poles. Middle attraction is less. Spread some iron fillings uniformly on a sheet of paper. Place a bar magnet below this sheet. What do you observe? Yes. So whatever the previous activity we did and whatever the iron fillings we collected, so that iron fillings we have to spread on a sheet of paper and keep a bar magnet under that sheet of paper. We will find that iron fillings reaches either side of the bar magnet. So the edges of the bar magnet that we will observe. For that first question, what do you observe means edges. Edges iron fillings reach more than the middle. Okay. Do you observe any change in the pattern of iron fillings spread over the sheet? Yes. So we observe that. What we observe? Down picture is there. So at the both edges, more iron fillings are there than the middle. So that we observe. You will observe that the uniformly spread iron fillings concentrate to 2 points of the sheet of the paper sheet. Okay. Yes. Why? The 2 points are bar magnet poles that we observe. Now coming to that. Distance you will find some scatters iron fillings between the 2 points. These changes in the sheet in the spread of iron fillings on the sheet of paper is due to the magnet present below it. So we kept a magnet under it. That is the reason that reaches to either sides. These iron fillings move toward to the ends because of this magnet. So that both ends of the magnet. Thus, the ends of a bar magnet attract more inner fillings than the middle part of the bar magnet. Middle part of the magnet. So, either side of the magnet attraction is more than the middle. So, due to that, the edges at the edges more iron fillings are there than the middle. By this activity, we can conclude that every bar magnet always has two ends whose attracting capacity is more than its other parts. These ends are called poles of the bar magnet. So what we are going to get the conclusion, every bar magnet has two ends. So the two ends attraction is more than the other parts, which means in the middle. So this both ends are called the poles of the bar magnet, which means poles of the bar magnet attraction is more than the middle portion. That is a conclusion. Activity 5. Finding directions with a bar magnet. Finding directions. Okay. Suspend the bar magnet freely with the help of a thread tie around its center as shown in figure 4. Does the magnet remain stationary? Wait for some time. What do you find? Okay. So we have to tie that bar magnet in that picture what we seen like that we have to arrange it. So leave it freely. Okay. You will notice that magnet finally take a position in the north-south direction. Mark the ends of the points toward north with some color. Now disturb the magnet and again wait for some time. Does the color portion come to rest? Repeat this activity at another place. What do you observe? So what it says, you have to arrange the bar magnet, suspended bar magnet in different places, and you wait for some time until it comes to rest. So every time it shows the same position, it comes to rest. Okay. Magnet always comes to rest in the north-south direction. That come to rest, that is in north-south direction. In each case, the marked end points toward north. This is known as north pole of the magnet. The other end which points toward to the south is known as the south pole of the magnet. This property of magnet is called a directional property. It is exhibited only by magnets. We use this property to make a magnetic compass, right? So the suspended bar magnet, red color north, other color is. So we mark color now, that is generally we use red color, that is a north color, north pole of the bar magnet, and the opposite pole is a south pole of the bar magnet. So that always comes to rest in a particular direction. Why that is a particular direction means north pole of the suspended bar magnet attract the south pole of the earth. Okay, opposite poles itself attract, that we know attraction repulsion. So this suspended bar magnet always shows that north south direction. So this is called a directional property. This directional property we will use to make a magnetic compass, which we will use to find out the direction of a place. Okay, magnetic compass we are going to discuss here. A magnetic compass is usually a small box with a glass covering it. A magnetized needle is posited inside the box in such a way that it can rotate freely. The compass has also has a dial with the direction marked on it. So what is a dial? So in that dial, in our watch, wristwatch, how 1, 2, 3 up to 12 numbers are there. In some watches, 12, 3, 6, 9. The same kind, east, west, north, south. So dial is there inside that magnetic compass. So a freely moving needle, magnetized needle, that is a magnet. Okay. The compass is kept at a place where we wish to know the direction. its needle indicates the north-south direction when it comes to rest. The compass is then rotated until the north and south marked on the dial are exactly below the two ends of the needle. So what it says, so that the needle rotates freely inside the glass box, so that needle comes to rest in a particular direction, that is the north and south direction. Until we have to wait, so it shows north south direction of that place. To identify the north pole of the magnet, what we will do, we will add some color. The needle, it is usually painted in a different color. Then we identify north and south at the place. After that, we can also identify the east-west direction. So if you know the north-south, we will know the east-west direction. So this is bigger magnetic compass. A magnetic compass is used to find out the direction. It is mostly used in ships, aeroplanes, mountains, and army people also carry a compass with them so that they do not lose their way in an unknown places. Okay, here already I asked yesterday a question. Who will use the magnetic compass? Magnetic compass used by mostly ships, aeroplanes, mountainous and army people to know the direction of the place where they are. Do not forget magnetic compass means compass and magnet don't place together because due to the another magnet the direction will change. So here we will know that attraction and repulsion between the two magnets. So unlike poles attracting, like poles repulsion, which means north repulsion, south repulsion, south north attraction is there. That is the properties of a magnet. What do you observe? So I observe that south repel, south attraction is there. Okay. When do the magnets attract each other? Unlike poles. Okay. North south. When do the magnets repel each other? South repel each other. You notice that like poles south repel each other, and unlike poles south north attract each other. Earth as a magnet, seventh activity. So for this we know that the seventh activity, suspended bar magnet we kept here itself. Then what happened? It comes to rest in a north-south direction. So after that, you have to use another magnet and bring it near to the suspended bar magnet. Automatically, that rest place is going to change because this magnet between that two magnets which we use under the suspended bar magnet. So due to that attraction and repulsion of poles, the direction will change. After removing that magnet under the suspended bar magnet, again that suspended bar magnet comes to rest in the previous place. So which means that shows a north-south direction. If you keep another magnet, that the south-north direction is going to change. So why without the magnet, always the suspended magnet bar magnet comes to that particular direction itself? What is the reason? So there is a hidden magnet is there. That hidden magnet is a earth. So the suspended bar magnet south attracted by the north of the earth. So that is the reason it shows the north of the earth and the same way opposite direction. Suspended bar magnet south of the bar magnet and it shows the north of the earth. So like suspended bar magnet directions, south attract to north of the earth, north attract to south of the earth. So that is the reason we can confirm that earth acts as a magnet. Now we are going to discuss about activity 8. What is this activity 8? Finding out whether the given object is a magnet or not. So this activity we did in the classroom. So you have to take one magnet and three same size, shape, color of the material. So here, what is the conclusion in this activity? If we take a object, if we kept near to the magnet, if both sides are not attractive, that is a non-magnetic material. Okay. If we keep the object near to the magnet, so one side attraction and one side repulsion is there, that object is a magnet. If both sides are attracted, that magnet attracted by the magnet, that is a magnetic material. For example, I am going to take one bar magnet and I am going to test it with the pencil. I will test it. I will test with that magnet. So pencil will not attract by the both poles of the magnet, south pole or north pole. So that is a pencil is a non-magnetic material. That is not a magnet or that is not a magnetic material. For example, I am going to take a iron nail. I am going to test with the bar magnet. So both sides are attracted by that iron nail. Both sides are attracted by the magnet, this iron nail. So that the iron nail made with the iron itself, no, that is not a magnet, that is a magnetic material, because that is attracted by the both sides of the magnet. Next, I am going to take another object. So that we know that is a magnet, but to confirm it magnet, if we test with that bar magnet, one side that magnet attract, another side repel. So one side attraction and one side repulsion is there. So that given object is a magnet. One side attraction and another side repel. That is a magnet. If both sides are attractive, that is a magnetic material like iron nails. If both sides are not attractive or repeller, that is a non-magnetic material. So given objects we can find out by using this bar magnet. That is about whether the given object is magnet or magnetic material or non-magnetic material. We can find out with that activity. Make your own magnet. So this we did it in the class. Take one bar magnet and one iron nail. We have to rub. So scratch. So figure 9 here you are looking. Like this you have to from the top to bottom and lift it again. You start from the top again bottom. So drag on that. So 20 to 30 times or 30 to 40 times if you do it, that iron nail change as a magnet. So that is so we are going to make our own magnet. The title is make your own magnet. So by doing this process, we are going to get our own magnet. So this needle change as or this nail change as a magnet. Okay. If we suspend this nail, okay, it comes to rest always in north south direction. We can mark north side one with one color. So that is a north direction and another one is a south. If you know the north and south, we will know east and west also. So this is we can use as a magnet and we will find out the directions of a place. So by using this needle, again 10th activity we are going to discuss. Make your own magnetic compass. So you have to take some bucket of water. Okay, take one thermocol sheet and this nail with the colored mark kept on the thermocol sheet and place tape on it without falling inside and add some detergent inside the water to move freely. Stir it and leave it. So after some time, this needle comes to rest in north-south direction. Because this is a magnetized needle, so this nail always comes to rest in a north and south direction. So this bucket of water along with the detergent, so this is acting as a magnetic compass now. By using this, we can find out the direction of your place. Clear? So you make your own magnetic compass means 10th activity you have to make your own magnet means 9th activity you have to Right. Next, magnetic induction. So the magnetic power passes in a chain system, that is magnetic induction. See here, safety pins and all pins if we attach each other. So what is magnetic induction means? You have to write this is magnetic property possessed by a magnetic substance due to this presence of a magnet near it is called magnetic induction. So if any one of the magnet near to the magnetic material, through that magnetic power passes to other magnetic material. So which forms a chain like structure, that is called magnetic induction. This is about magnetic induction. So this is the answer. These 4 lines you have to write. What is magnetic induction? Magnetic property possessed by a magnetic substance due to the presence of a magnet near it. So one magnet is near to the magnetic material. So that magnetic power passes through the magnetic material to another magnetic material and both are attached. So that is called magnetic induction. If a safety pin is not in contact with the bar magnet, can it attract the alpin? Yes. Okay. What happens if we place the bar magnet very close to the safety pin but not touch it? So that may not be contact directly, but the alpin which is attached to the safety pin, through that safety pin, that magnetic power passes and it is attached to the safety pin continuously. Okay. So this is magnetic induction. See here, this magnet power passes through this safety pin and it attracts the alpin. This is the 11th B picture indicates. This picture shows that magnetic induction. Okay, this is about playing with the magnets chapter. So here what we have learned, what we are learning here. Improve your learning, we are going to discuss. Predict with the following materials are magnetic or non-magnetic material. Test with a bar magnet and check your prediction. What do you say after testing all material? So I explained to you plastic. So how we are going to write this answer? First, our prediction we want to write. So I am going to test this plastic. My prediction is plastic will not attract by the magnet. So after testing, what is the result? Attracted or not attracted? Not attracted. So your prediction is right. For example, I thought that I am going to. I thought that this plastic is going to attract by the magnet. So after testing, what is your result? In your prediction column, what you are going to write? My prediction is wrong. I thought that a plastic attracted by magnet, but plastic is not attracted by the magnet. That is a result. Like that, iron, stainless steel, wood, aluminum, gold, silver, copper, paper, cloth, etc. So except copper, iron, okay, remaining will not attract by the magnet because iron, nickel, cobalt, material itself attracted by the magnet, remaining will not attract. So your predictions you can write and you test it and you find out that result. Okay. List out the magnetic and non-magnetic materials in your classroom. So already we wrote it, which are made with the iron, those are magnetic, which are not made with the iron, those are non-magnetic, that list we wrote. So third question, for which purpose do people use magnets in their daily life? Ask your family members and other elders and collect the information and prepare a list of uses of the magnet. So in our daily life, we use TV. Inside the TV, speakers are made with the magnets. Fan, okay. Inside the fan, magnet is there. In our vehicles, magnet is there. In mesh doors, magnet is there. Okay. So in phone pouches, magnet is there. So stickers which we attach it to the almara or beerwas, magnet is there. So refrigerator door, inside the refrigerator door, magnet is there. So where rotation is there magnet is there. Because due to that we will do the activities. Without magnet, it cannot rotate because the power will not pass. Draw a bar magnet and locate the poles. So కింద ఉన్న ఒక picture ఉంది అది says south and north poles you have to. So here this picture if you observe both are attached to each other. So attraction is there, which means north attract the other bar magnet south. So that is south and north you have to write. North to south and the opposite side is south. North. Same you have to write south and north on this. Think and say in which direction your house is facing. So by using your magnetic compass, you are going to find out the direction of your place. Okay, use the magnetic compass and magnetic compass. Find out the exact direction of your house and compare it with your prediction. So same prediction means you have to guess. I think my house is my house facing toward to the east. So with the magnetic compass, if I test is it east facing the, so then we are going to next. Similarly, predict and find out in which direction you keep your head while sleeping at night. So that also with the magnetic. If you know the house facing, then you will know which side your head you are keeping while you are sleeping. The direction of your facing while you are reading, eating, etc. So with the help of the magnetic compass itself, we will find the direction of a place. That by making your own magnet, by using that, you can get one magnet and magnetic compass and find out that. Prepare your die using the magnets and write the procedure of preparation briefly. So attraction and repulsion by using these magnetic properties, you can prepare a toy. So opening and closing are moving up and down like sieving, oscillatory motions. Anything you can make already we discussed like butterflies are opening and closing. Think and say where the poles will be located on in a ring magnet. Try to find out its poles using a magnet, bar magnet, and check your. So actually, bar magnet poles we can find out easily, but ring magnet every side half acts as a south, half acts as a north pole. The opposite side quite opposite, north and south and north like that. Half of. Next, we are going to discuss about ninth magnet. Ninth magnetized needle using a bar magnet. Make a compass with a needle by following this process. Explain. So you have to make your own magnetic compass. That is, sometimes people use magnets to keep the doors open and sometimes to close the doors finally. Think and say how it is possible and how we should arrange the magnets each other. So to close attraction, unlike poles. To open like poles repulsion. In such a way, we are going to arrange the magnets. Does the earth behave as a magnet? How do you prove it? So seventh activity, the suspended bar magnet always comes to rest north and south direction because north of the suspended bar magnet attracted by the south of the earth, south of the suspended bar magnet attracted by the north of the earth. So we can prove it. There is a hidden magnet that is the earth. Okay. If you have two similar bars, one magnet and another a piece of iron, can you find out which one of these is a magnet and next one? So already we discussed that. So if the given object is a magnet, so it attract one side and it repel another side. If given object is a magnetic material, it attract by the both sides of the magnet. If the given object is not attract or repel by both sides of the bar magnet, that is a non-magnetic material that we can. Teacher said that earth is a magnet, but Sridevi has some doubts and she asked her teacher some questions. What may be these questions? So ask your doubts, asking hypothesis and making questions. So that is your doubt. You can write some questions. What doubts? That is your own questions. Surya has wondered, struck to know that Earth is a big magnet and appreciate the efforts of the scientists to discover this. Okay. Do you notice any such a things in magnet to appreciate? Explain. No doubt, Earth acts as a magnet. This discovery is very, very useful to us to live comfort manner on the Earth. With that magnets, attraction, repulsion, with that magnets, we are going to make different appliances which we are using in our daily life. We should appreciate them. Okay. So many places magnets are there. Kiran wants to prepare a toy using some magnets to make people understand the slogan, reject a bad food and accept a good food. Can you help him to prepare? Yes. So south to south side when we keep, so reject bad food we have to write. And north south or south north side we have to keep good food accept. Okay, unlike poles, attraction is there, that is a good food and accept. Like poles, repulsion is there, that is a bad food result. So with that we can arrange. So this is about the second chapter. Okay, all questions and total chapter I explained here. You go through the textbook and read once again the textbook and so here what are magnetic material, what are non-magnetic material, what is magnetic induction, what is magnetic compass. If you suspend a bar magnet, what does it show? Okay. If the given object is a magnet or magnetic material or non-magnetic material, how do you prove it? How do you prove Earth as a magnet? So how can you make your own magnet? How can you make your own magnetic compass? These are all the questions. So find out some of the magnetic and non-magnetic material in your house, in your school. So what are iron fillings? How do you separate the iron objects from the mixture by using the magnet? So these are all questions, general things which will happen in our life where we will use the magnets. About that you have to collect some information. Right, this is a second chapter completed. So one more chapter that we will discuss tomorrow evening, that is the brain. Where does it come from? Okay, bye bye, see you.